apologies for those technical difficulties earlier. Being out here on the water, sometimes it makes it tricky to be able to have us connect to all of you. And right here, I'm out on our boat, and woo, it sure is bumpy. My goodness. But part of the reason why we're out here today is, of course, to be able to discover Earth. And here we go. Do you see that with me? Wow! Are those... No. Are those orca? Do you see them? Wow! That's just incredible! Wow! Wow, folks. Wasn't that incredible? All of these orca right behind me. Now, today we are discovering Earth. So we're going to be talking about some of these orca and maybe how they relate to Earth in general. Now, the way that you can go on ahead and engage with us today, my name is Jen, and joining me in the studio is Cynthia, and we have Kaya at the computer bringing those texts and those questions right on into the studio. You can always get a hold of us by texting down below, 562-286-1838. And if it is much later on, feel free to go on ahead and email us down below at live@lbaop.org. Now remember, if you are a younger viewer, texting rates do apply. So please keep that in mind. Now, love all of your questions as we continue to explore Earth. Now, I was just on a boat, and I'm still feeling a little woozy from being out there, and our boat was rocking back and forth. There were lots of waves everywhere, and we weren't very far off the water. And as we were on the water, we noticed those orcas. Now, why do you think those orcas were there in that water? Well, my guess is maybe the orcas were hungry. Maybe they were looking for some food, right? Maybe they were looking for salmon to eat, or depending upon the variety, they may be looking for tasty marine mammals like seals or sea lions, or maybe even a whale. But in order for those fish and marine mammals to be there, that means that there has to be food for them too, right? So that means that there has to be some smaller fish. And if there's smaller fish, there's probably birds around too. Wow, and that's a lot of animals, a lot of life that's right off of our coast that we had a chance to see. Now, I wonder if it's the same productivity as what we call it, right? The amount of animals and all of that life, I wonder if there's the same amount in the middle of the ocean. What do you think? Let's find out together. Let's see. Cynthia, what can you show us? I don't see anything, do you? I'm not seeing those orcas. I'm not seeing those big waves, though I guess it is sunny, so it's pretty nice out. But I didn't see any birds. Did you? Nope. No breaching whales, no orcas doing anything. I don't see fish flopping out of the water. Looks like maybe, at least from the surface of the ocean, there's not as much activity. And I wonder, is there as much productivity, a lot of life that's found underneath? So let's go on ahead and explore that today through our program known as Discover Earth, the quick version since we had technical difficulties. All right, friends, so I'm going to put my Explorer binoculars down, and I'm going to step off screen because I am going to bring up my tablet that I happen to have here. Now, the great news is, if you'd like, you're more than welcome to join along at home. This is our Science on a Sphere app. So it works on a computer too. It works on a phone. It works on a tablet. Whatever kind of, techie device that you happen to have, you can download the software. And what it does is it brings up everything that you're seeing here. Now, all of these are different kinds of playlists that we happen to have. And so here's one of them behind me. And you can change it from air to all to land. There's so many different types of classifications that you can use to show our entire Earth right here. So right now I have it on all. I'm going to go over to water because today we're talking about the ocean, right? And why we're finding so much life at the coastlines, a few miles off of our continents that we have here in our countries, and why we might not be finding as much in the very middle of the ocean. So I'm going to go on ahead and I'm going to change it to, let's see, our ocean here. And I'm going to try to bring it back to kind of earth right here. And I'm going to bring up buoys and floats. Now, I'm going to minimize our window here so we can maximize what we're seeing on screen. And here we have our Earth. And today, what we're doing as we're looking at our science on the sphere is that we're looking at different kinds of data sets. So if you're not familiar with the word data, it actually just means information. So we are looking at information in a picture form, which is one of my favorite ways to look at information because there's lots of fun colors and shapes, and you can really kind of take time and look at it almost like a beautiful piece of art. Maybe a beautiful piece of sciencey art today, right? And so here, this art does have meaning, and it has meanings in the forms of colors and shapes and keys that help us try to figure out what we're looking at. And as we're looking at this, we are getting a chance to see a lot of these images from satellites. So that's how we're able to see a lot of these views, but not only through satellites, but also through buoys as well. So buoys, of course, are going to be fine in the water. They're basically floating pieces of metal that are light and that are anchored down into the ocean. And these buoys help do a lot of different things. These buoys help us to be able to know if we're getting close to land, right? So those captains of ships may be able to hear the sound that the buoy makes and know that maybe they are getting closer to land, and it's a marker. Other times, buoys have sensors and lots of different science equipment on them to help figure out maybe they're looking at the temperature of the water, or maybe they're looking at the tidal height, right? Earlier on when we were on that boat, the waves were big and we were bouncing back and forth and all over the place. Now, other times it might be really calm or maybe just small little waves, right? And so buoys, as they also go up and down, they can figure out the tidal height, right? How high are those waves? Now, we did go on ahead and say that a homeschool group didn't see anything on the ocean either, right? In the middle of the ocean, there wasn't too much exciting. Not to say that the middle of the ocean is not exciting. It's just not what we're going to be focusing on today, right? So our focus is going to be, why is it that we see so much life, right, along the coast right here, and not so much in the very middle of the ocean? Now, buoys are helpful in the middle of the ocean because it's also a lot harder to get to. So it's really helpful to have some of the scientific, information out here so that way we can learn more about what's going on in that very middle. It could be our eyes and our ears, and we can get a lot of this information transferred back to us here on land via satellites. So we just ping it back up to that satellite, and then we're able to get that information. So let's go on ahead and let's look at another data set within our world right here. And I'm going to bring up one that's within our water. Oops, I'm going to see if I can move that down. Here we go. And we're going to do this one. So I'm going to scooch it on back a little bit. It takes a little while for these to set up. Now, Cynthia, if you wouldn't mind just getting rid of the question bar for us so we can see a little bit below. It just happens to be sitting directly there. Thank you. So here we can see, well, what do you notice? It's the sea surface temperature model, right? Now, on my screen, it seems to be a little bit grainier than usual, and I see that happening there. Not to worry, I'm actually going to load up another data set. Sometimes certain data sets come in a little bit clearer than others. So here we have our world again. Here we have our surface. Oops, this is our surface temperature. So this is for all over. There we go. We're looking for sea surface temperature. All right, third time's the charm, right? Oh, and it's blurry again. That's okay. We can get the basic colors, right? So sometimes maybe satellites don't always upload the images the way that we like them to, but that's okay. So, and it might be clearer on your computer at home. But the important thing to note here is the pattern. So I'm going to roll our Earth around, because you could probably do that too at home, either with a mouse or maybe with your hand if you're using a touchpad. But what are you noticing? I can definitely notice that there are certain color bands, right? And those color bands kind of help me figure out what temperature we have that's going on here. I can figure out that red probably means hot, right? As we're seeing right down here, that's hot. And then I'm seeing maybe an orangey color, so maybe the red and the yellow are kind of mixing together. So we know that it's like still pretty warm, right? And then I'm seeing lots of bands of green up here. So we know that the temperature is getting cooler. And I'm wondering if you're thinking that too. What color is it at the poles, right? We can see a little bit, but let's check it out. Let's flip our Earth. Ta-da! And here, was it what you expected? Pretty cool, huh? We are seeing that the water is cooling down, going to super cold, and then we hit ice, right? Super solid ice right here. Now here, within our data set, we are only seeing temperature of the ocean. So our land, even though it is kind of colored, it's modeled after the kinds of plant life that we would see, or vegetation that we would see on our countries right here. So that's kind of what we're seeing there, right? All of the vegetation changes that we're seeing. So, oops, our world is very much tilted. There we go, right? So we're seeing all of these, the land vegetation, and maybe how there's a lot of desert in some areas, right? Versus greenery in other areas of the world. And so, but our focus is going to be on that ocean. There we go, kind of tilting it out. There we go, right? So why is it that we seem to have that red at the very middle? Why is it so hot right along the waist of our Earth? Well, what do you think, Cynthia? Ah, she says the equator, right? Exactly. So here is our equator line that we have. Thanks for letting me put you on the spot, Cynthia. She did it. So here we have our equator line, right? It's where we have the sun, and it is shining down on that middle part right here. And it's shining the brightest, and it's shining the hardest, right? So here we have it nice and hot. And since our Earth is, well, not a square, it's a circle, right? The shining of the sun is not the same intensity or brightness all around our entire world. And we're also somewhat tilted too, right? Let's see if I can tilt our Earth a little bit, right? And so since our Earth is tilted a little bit and our Earth is round, we get different light intensities depending upon where we are. And that light is transferred into heat into our ocean. So that's why we have that reddish band right there. That's the hottest. And then it gets cooler, cooler, cooler. Up we go. And then cooler, cooler, cooler. The farther down we go too, right? Now, not only is the sun affecting our Earth by heating up the water or having it cooler in certain areas, but it also affects our wind patterns too. So I'm going to go on ahead and get that wind pattern up. Now, it's not going to be within our water column, so I'm going to go to, I think it's under air, and from that, I'm going to scroll on down. And Shinja says, because the sun hits it more directly, you got it, nice job, yeah. So that equator line is right where we have all of that super bright sun that's like, I'm going to warm you up the most, right? So, nice job, Shinja. All right, so here we go. Our goal is to find one that says air wind stream. So here we have the wind streamers. I think this is the one that I want. Let's see. It should be nice and colorful. So this is a fun data set, which I'm excited to share with you. All right, so here we're looking, here's our key, right? So usually our data sets have a key that helps us figure out what's going on. And we're looking in our world now in a completely different way that you may have never looked at it before. And frankly, for me, this is the first time I saw this data set, was a little bit ago, and I loved it. So I'm very excited to share this one with you. And here we have basically meters per second. And so that's telling us the speed that we're seeing. So that blue is going to be super slow winds. And the higher up we go in the colors, or the brighter colors that we get, the faster the winds are. Now, my goal, though, is not to look at wind speed, but the direction of the wind, because the sun also, and the heat that's being brought onto land, just like how Shinja mentioned, right, are ways that affect our clouds and our wind patterns too. So, what do you notice here? Ooh, my. I think it has to reload. All right, so I'm going to have it right over here. And as it gets a chance to kind of buffer and to clarify in a little bit, Our internet connection is very slow today. Sorry about that, friends. You should be able to see a general pattern, and we could see it going real slow right now. But is our wind going in the same direction everywhere? Not so much. Cynthia's like, she's shaking her head. She's saying no, right? And so if we notice here, we have some of the winds, they're blowing, perfect, from west to east, right? So our weather always goes pretty much from west to east in some sort of pattern this way, right? If it's not going this way, it makes a circle that goes from west to east. It kind of goes in a clockwise sort of direction. Well, guess what? Down below, is it going that same direction? It's actually going the opposite direction, but it's going still in that circular motion, right? Guess it has to take another minute to buffer. But so our wind patterns are going, at least on the northern hemisphere, right, are always going from west to east. So now we have an idea that the sun's power, right, not only helps the winds move and the cloud patterns move, but it also helps us figure out the heating of the ocean. And believe it or not, there are currents underneath the water too. Yep, there's currents that help move water kind of in a similar way. What happens is we have a lot of water that is warm on top and cool underneath. And that warm, cool water basically helps us to provide currents that travel all around the entire ocean, right? And all over the entire world. And these currents, especially off of our coast right here, bring up lots of nutrients. Now here, off the west coast, we have something that's called upwelling, where we have lots of cool water that's coming from down below, and it's hitting up against our coast. And it goes upwards. So all of that cool, nutrient-rich water that has a lot of different kinds of vitamins like nitrogen and carbon and iron, all those things are great for the base of the entire food chain, being phytoplankton, these plant plankton. Now, I do have a data set that allows us to be able to see all of the plankton. So we have to go back to water. And then we're going to be going to one that's called phytoplankton model. Here we go. So here we're going to bring it up. And the goal right here is just to notice the pattern. So ignore the key. These are just different kinds. But our goal is to see and try to figure out, where are we seeing most of these colors? The green, the blue, the red, and the yellowy color, right? So where are we seeing them? Are we seeing them mostly in the very middle of the ocean? Are we seeing them towards our countries, right? What are we noticing? So here, we definitely have some towards the middle of the ocean, but otherwise, where are we seeing them? I see really bright colors up along right here, right? Look at all the brightness up here. I'm not seeing too much in the very middle of the ocean, are you? Interesting. So the base of our ocean food web, right, all of this phytoplankton, wow! Do you see all the red down here? Well, that's incredible, right? We're seeing all of them near the edges of most of these continents. Now, there's some areas where it looks like there might be some exchange, right? They're not super far away from each other, but areas right here in the middle, not too much of this base of our entire ocean food chain. So if we think about our plant plankton and they're the base of the ocean, I'm curious to know, what about those animals that like to eat them? Like fish, right? Because we were looking at orcas earlier. And orcas sometimes will eat fish, or at least the marine mammals like seals, sea lions, birds, they'll also eat fish. So let's go on ahead and let's look at one last data set today. It's called fisheries richness. And so that's looking at all the fish in the ocean, or at least a lot of them. It's hard to count every single fish. And then we can try to see, where are we finding the most amount of fish? All right, so let's go on ahead and let this data set load on up. And here we have our helpful key again, right? So here we're seeing 0, which is basically black, right? Nothing there, all the way to kind of warmer colors, right? That yellow and that purple is kind of in between. And so what we're tracking are different numbers of different species, so different kinds of fish. And so as we're looking, let's see, where are we seeing the most amount of fish? getting a chance to see? Remember, most is going to be that yellow. So see if you can find any patterns. Oh, see lots of dots. Whoa. Do you see that? That's incredible. All of that yellow that we're seeing just basically is like a highlighter all around all of the continents, right? Look at that. Within Europe and Africa. We're seeing Asia too, Indonesia, Australia. Isn't that amazing? Not too much in the very middle of the ocean, huh? Again, there's little spots. But why do you think there's those little spots? Right, because there's islands right here. So again, near land. Wow. So that means we're seeing most of the food that is right next to the land where all of those phytoplankton are, where all of those nutrients are that are coming up from all of the winds that's being blown, and for the warming of the water, all from the sun. Isn't the earth incredible, friends? Oh my goodness. Oh, unfortunately we are out of time, but I just wanted to say thank you so very much for discovering Earth with me today and seeing and getting a better understanding of why we saw all those orcas right next to shore and why we didn't see very much life, at least on the surface, right, on our second cruise, because there wasn't a whole lot there, much like how many of you mentioned. All right, folks. So thank you so very much for joining us today. Cynthia, I don't know if you can get me back on that boat to be able to watch and see if I can find any more of those whales. But if you do have any further questions, feel free to go on ahead and email us at live@lbaop.org. And let's see if we can maybe get back on that boat. I need to get my binoculars. Here we go. All right. Let's see. Let's see if where we're gonna be headed off to next. Oh, it's like a cruise on a beautiful sunset. Let's see if we can find anything. I'm seeing that sun. I'm seeing an awesome audience that joined us today for our Discover Earth program. You know what? Even though I'm not seeing any animals, I'm going to enjoy this calm, this beautiful sunset. I think it's a great time to maybe grab a snack and maybe an iced tea and lay back and enjoy the ride. All right, friends. Have a great rest of your day, and thanks again for joining us today on the Aquarium Online Academy. Take care. Is that a Cynthia? I think that might be a Kaya out there. Ready for that snack.